Kita mulakan sesi malam ni dengan umur kita Al-Fatihah. Okey, bersama dengan kita hari ini ada Encik Anwar Farid dari batch SPM 2009. Kita juga ada Cikgu Aisyah dengan Cikgu Syahid selaku wakil unit bimbingan kaunseling MRSM Taiping. Para pendengar, para alumni dan juga adik-adik pelajar MRSM Taiping lah. Selamat malam saya ucapkan dan selamat tahun baru. Jadinya hari ini bertemu lagi kita dalam ANSARA Muda Career Talk Series untuk sesi Januari 2021 insyaAllah. Jadi untuk speaker kita malam ini yang pertama lah untuk tahun ni, Cik Anwar Farid dari batch 2009, seorang proses control engineer. Dalam bahasa Melayunya jurutera kawalan proses. Betul ke Cik Anwar?
Betul.
Betul, okey. Sekarang bekerja di Malaysia LNG Sdn Berhad, sebuah subsidiary Petronas, betul kan?
Betul.
Okey. Jadinya insyaAllah kita akan teruskan sharing session kita pagi malam ini. Saya pas pada Cik Anwar lah, boleh teruskan.
Okey. So share screen.
Okey, nampak.
Okey, so semua nampak ya? Screen.
Alright. Nampak.
Alright. Okey. So bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat malam semuanya. Okey, jadi seperti yang Tasnim, terima kasih kepada macam majlis Tasnim. Seperti yang Tasnim dah perkenalkan tadi, saya Anwar Farid. Boleh panggil Anwar. Batch SPM 2009 dan dari kelas 11 lah, mungkin dulu. Okey. Masa tu bawah Puan Rihmi lah. Puan Rihmi dah bersara dah pun ya. Tapi masa tu Puan Rihmi lah cikgu homeroom kami. Okey. So kita terus masuk kepada tajuk. Terus masuk kepada tajuk kita. Okey. So kita pergi pada sedikit timeline lah, sejarah sikit. Okey, jadi kita mula daripada 2008. Kita kenalan sikit lah. 2008 ke 2009 di MRSM Taiping, macam saya cerita tadi. Ambil 9 subjek je, tanpa subjek elektif, dan masa tu di bawah Puan Rihmi lah. Dan dari segi co-curriculum, yang saya sempat sertai adalah jadi ahli exco bawah BWP lah. Masa tu exco kesenian dan kebudayaan, ataupun nama dia masa tu Hercules, Heritage and Culture Exco. Okey, dan masa tu alhamdulillah dapat 5 A+ lah, 5 A+. 3A, 1 A- masa tu. Dan dengan keputusan SPM tu memohon untuk masuk ke seterusnya 2010, memohon untuk masuk ke beberapa tempat lah masa tu. Antara yang saya pohon masa tu ada daripada MARA, ada masuk ke matrikulasi, dan ada juga masuk ke Universiti Teknologi Petronas lah masa tu, Tajam Petronas. Dan alhamdulillah dapat masuk lah Universiti Teknologi Petronas di bawah Tajam Petronas pada masa tu. So kami adalah batch pertama setelah berapa lama. Kami adalah batch pertama pada masa tu 2010 yang ditaja lah, bukannya dapat beasiswa. Okey, biasanya beasiswa maksudnya dia habis terus. Kalau tajaan maksudnya akan ada timbal balik lah setelah bergraduasi. Okey, dan tamat ataupun graduasi pada 2015, dan pada masa tu sambung kerja sikit lah sementara menunggu dapat kerja tetap, bekerja secara sambilan menjadi pembantu penyelidik di UTP juga. Sebelum 2015 terus bekerja di Malaysia LNG Sdn Berhad, anak syarikat Petronas sampailah sekarang. Okey, sedikit latar belakang lah. Malaysia LNG ni kerjanya ataupun peranan dia adalah untuk merawat dan juga menyejukkan to treat and liquefy natural gas, menyejukkan gas asli kepada LNG dan juga LPG. Okay, kalau kita sentuh sikit lah pasal topik kimia sikit kan. Kalau dalam sebatian karbon compound, kita ada C1 sampai berapa lah kan. Tapi C1, methane, ethane, lepas tu propane dan butane. So LNG dia ada 4 sampai butane. Kalau LPG saja dia hanya ada propane dan butane lah. Okay. So dapat kerja sebagai proses control engineer dari 2015 sampai sekarang lah. Dah 5 tahun dah. Alhamdulillah. Okay. Jadi seterusnya, okay, apa yang seorang, kalau kita nak simpulkan atau kalau kita nak rumuskan apa yang seorang jurutera kawalan proses control engineer buat, saya bagi contoh yang betul lah, contoh yang agak ringkas lah apa yang kami buat. Okay, jadi ni agak teknikal sikit tapi saya cuba ringkaskan semudah yang boleh lah. Okay, ini adalah bahan asal kita, bahan mentah kita, gas asli yang dari suhu asalnya 30 darjah Celsius masuk ke dalam satu benda yang kita panggil sebagai MCHE ataupun cryogenic heat exchanger lah. So cryogenic maksudnya suhu dia suhu beku, suhu untuk nitrogen jadi cecair, LNG menjadi cecair. Okay. So kita masuk sampai ke suhu negatif 160 darjah Celsius lah. Maksudnya kita sejukkan di sini bukan saja sejuk daripada 30 ke negatif 160, kita juga tukarkan daripada gas pada suhu 160 kepada cecair di suhu 160 darjah. Jadi untuk membolehkan benda tu berlaku, kita memerlukan satu benda kita panggil sebagai refrigerant ataupun cecair penyejuk yang akan mengambil semua haba tu lah. Okay, mengambil semua haba tu daripada gas tadi untuk dia akhirnya turun sampai ke suhu yang sejuk dan akhirnya jadi cecair keluar kat sini. Okay. Jadi kalau kita nak ambil contoh kepada situasi ni ataupun proses ni, apa yang seorang control engineer akan buat? Pertama sekali dia akan pastikan, okay, first, a process control engineer needs to ensure stability. Okay, what do I mean by stability? Okay, first we observe this part here lah. So as you can see, the fluctuation here, the refrigerant flow is heavily fluctuated, or in statistic term we say high standard deviation lah. Okay, so first what we do is we ensure that the flow is stable on the second stage. Okay, until we come second stage. So quality here means we need to ensure the quality of LNG. One of the aspect to ensure the quality of LNG is to ensure it operate, our product is at the correct temperature lah, negative 160 degrees. Okay, as the quality can be maintained, we can increase the output, we can increase the production of our LNG to higher value, and then as the time goes by, we try to make it more efficient. That means we either increase production with same amount of refrigerant, or we produce the same amount of LNG but at less refrigerant, less resource lah. So to sum up, what process control engineer do in whatever industry, whatever field, whatever line of work is to ensure first process stability, quality compliance, to keep up with the production target, and then to make the process as efficient as possible. Alright, next. Okay, to give a glimpse or to give an overview of process control is not isolated, not an exclusive field actually. Despite being a subtopic under chemical engineering at degree level for engineering university lah. Okay, but in our line of work, we also need to have some knowledge, and although not deep, some knowledge on instrumentation and control. So instrumentation and control is under line of work of electrical engineering. Process technology, design, economics, safety is other subtopic of chemical engineering. So in chemical engineering, we can split into process design, process technology, we have process safety, economics, production planning, and lastly, plant operation. So plant operation is the way we use, the way we handle our equipment. How do we ensure the manning, the manpower allocation. So a process control engineer needs to have a little bit of knowledge in everything, not knowing completely lah, obviously. At least some knowledge in these three fields to ensure that the four objectives that I mentioned before can be achieved, which is stability, quality, production, and efficiency. Okay. So in this kind of work, collaboration is something that highly required and not to say highly required. It is compulsory lah. You cannot function without collaboration.
Cikgu
Okay.
maaf
Yes.
mic tu boleh jauhkan sikit tak sebab dia macam berdengung sikit. Okay.
How about now?
Fine. Ya,
Okay.
better.
Okay.
Awak
Is it echo lagi?
macam sikit. Macam alright. Boleh try. Hello? Alamak, terputus. Hello? I cannot hear. Tak boleh dengar.
Hello?
Okay.
Okay. Okay. So where were we? Okay. Do I need to repeat the last slide?
Tak apa, boleh sambung.
Okay. So next, since I was told by the organizer to include some parts that requires and some parts that is required for you guys to further your studies and then into career. So I present the slide in this manner lah, which is usually in whatever resume, whatever even in interview, all these three things will be evaluated, which is your attitude, your sikap, skill, kemahiran, and your knowledge, ilmu. Usually we previously we always have tendency to focus more on knowledge, which is our CGPA, our our grades. But as time goes by, we know that it requires more than just your grade, your academics to further your studies and to pursue your career. We also need to know that do you have the right attitude and the skill required lah. Okay, so in this line of work, in process control engineering, what kind of attitude or behavior that we always observe that is required to ensure smooth working is first, you always have to be curious. Okay, be curious to the point that how to say, there's a term lah, we always use chronic unease. Rasa tak senang duduk. So curious means you always want to know deeper. You want to know, okay, habis tu, okay, after that, is there more? Is there anything more? Is there anything I miss? So and then by curiosity means we don't just hear from one party lah. Okay, for example, the plant is operated by our technicians. Okay, technicians say, I've seen the behavior of the equipment is like this. Okay, so by using your curiosity, you should ask further. Okay, that is what the technician said. But how about the data recorder or the plant information system? How about the other process engineer? So your curiosity allows you to pursue further.
the answer. And second, persevere. In pursuing the answers to create the solution, we need to have perseverance or patience lah. Without patience or perseverance, you be sure to give up instantly. Because problems in our plant, problems in industry are seldom easily explained by theory. Okay, for example, in theory we learn that ideal gas law kan. Okay, as the pressure increases, temperature increases. But sometimes the opposite happens. We increase the pressure, we increase the temperature, but the pressure drops. So it's not to say that our plant is operating outside the realm of physics, but there are something is happening that needs further investigation lah. And then to be cautious as well. Sometimes too many information is still bad to you. Sometimes we tend to waste our time in analyzing or gathering information that is either useless or not useful now. So we need to prioritize or to determine which one is required now and here lah. The fourth one, as I mentioned, is to be collaborative. Process control or plant in general, plant operation in general is a collaborative effort. We need the technicians, we need the people who knows the design, we need the people who knows the economics. Okay, for example, this is since my plant is only operating at LPG and LNG, the economics is simple. You produce more, you get more money. But then some other plants, for example, in refinery, penapisan, the refinery tower has lots of products. Sometimes we have diesel, we have kerosene, minyak tanah, we have diesel, we have gasoline, we have bitumen for tar. As the day goes by, the price of each product is not the same. Sometimes product A is higher. The next day, product B has higher price. So we cannot maintain the same amount of production every day. So of course, we are targeting, okay, this price have the highest value for today. So we prioritize the production for product B, for example. So without collaboration, without knowing that people from finance department telling us, okay, you need to produce more of this product, you need to stop this because it's not making any money for today. So we will be at loss, and even at maintenance. And 5, okay, is lifelong learning. Nobody in working, even in study pun, become expert overnight. Nobody become expert overnight lah. Tak ada siapa yang pandai serta-merta kan. Okay. So we need to accept that we always have the necessity to always learn, unlearn and relearn. Belajar, tak belajar, lepas tu kita belajar lagi sekali. Because, okay, why we need to learn? Because we need knowledge. Why we need to unlearn? Because we need to ensure that whatever we know now or previously doesn't hinder us from learning something new, and then to relearn again lah. Okay, and then as for skill, we go fast lah. Okay. People management, we need to manage our manpower if we become of higher position, but even amongst the same level, even amongst executive, amongst our colleagues, we need to manage our strengths and weaknesses accordingly. Some people are expert in some parts of process control, for example, statistics. So statistic related work, we leave it to him or her. We know our strength, we utilize our strength well lah. And then time and project scheduling. So projects can be individual, can be collaborative effort, but nevertheless we need to know when and if we can comply to our timeline lah. And then data collection, cleaning, analysis, obviously, because the data is new oil. Data is a commodity nowadays. So we have to ensure that we collect the right data, we clean the data from whatever that is unnecessary, and we analyze it as per required lah. We don't analyze until we are satisfied. We analyze until we can do whatever that is required from us. Okay. And then service orientation. Because in business, in whatever business, customer is not always right, but customer is prioritized lah. Okay. Customer is not always right, but customer is prioritized. That means whatever that is required from our customer at that point in time must be delivered. Because if we act later, that means there is potential that the customer needs has already changed. So when we deliver the product from yesterday to our customer today, he or she may not need it anymore. Okay. So we must always closely engage to our customer. And then 5, algorithmic mindset. That means we must see everything. If I'm not mistaken, we still learning computer science. So in computer science, we learn the sequence of steps, the algorithm, the condition. If this happens, what to do next? Else, what? Is it all condition and condition? We need to view that in the light of algorithm, because process control engineer and automation cannot be separated lah. We live by automating the process that is usually be done manual. If anything can be done manually with consistent result, with accuracy, that means we can automate it. But before we can automate the process, we need to run it in algorithm lah. Simple, we can do it in even our daily tasks. For example, please observe every time we wash our dishes, every time we eat, for example. Okay, kita makan biasanya apa? Kalau makan nasi, lauk yang sedap kita letak last. That is algorithm. That is algorithm. We eat the rice first before the yummy stuff lah. Okay. Alright. And then lastly, knowledge lah. Okay. So roughly what kind of knowledge that we need in whatever process or plan that we operate is mass and energy balance. How much mass is going in and out, how much energy is entering and going out. Kinetics and reaction. In chemistry, we learn about rate of reaction. Okay, that is tip of iceberg lah, but that is roughly what is happening. We need to know about the rate of reaction, if any catalyst is required, what's happened, what's inhibiting or what's supporting the reaction. Programming in relation to algorithmic mindset, we need to know programming lah. There are many programming languages, R, C++, Pascal, Python, HTML. Okay, but the most basic that I have encountered lah for plant utilization is R. R is the easiest language to be understood by our machines lah. Okay, HTML is if you are going for more advanced machine. Economics, as I mentioned, at least we know the prices of each of our products and each of our resources. Okay, raw material is one thing, but then we need to consider the utilities, how much electricity, water, steam that we use, etc. And engineering mathematics. Okay, why do I put engineering here? Because mathematics is wide and there are many schools of thought lah. Okay, so when we put engineering here, that means the applicability of mathematics can be seen through physical means. That means we can see the result in our plant, not something that is theoretical lah. Okay. So in relation to job requirement or interview, for example, okay, the first line of filtering, of course, the recruiter will view the knowledge, your CGPA, your grades, for example. Okay, I want to filter the students with at least CGPA of 3 and above. But that is just the first stage. The one that finally determines your hired or fired, hired or not, is these two lah, attitude and skill. That means usually we portray in our resume or in our during our interview. Okay, next. Okay, in what kind of higher learning institution or IPTA or IPTS we can learn? Okay, the one that I'm listing here is just in Malaysia lah. Obviously, there are lots more options abroad. But as far as my experience goes, if the most of the higher learning institution internationally, we can learn process control as a subtopic of chemical engineering. So if you find yourself any international university that has chemical engineering, chances are you will learn about process control for degree. And then for deeper knowledge, you need to do master yourself lah. Okay, but the ones that I'm listing here is local ones. Even this one is lots of number, and this one is referred to MyPCS, Malaysian Process Control Society, which is consisting of students and lecturers from various university that has research or that is teaching on process control lah. So these are all the campuses that is in Malaysia, both international and local and IPTA, IPTS. Okay, so we have UKM, UTM, you can view lah here. Nottingham, UITM, USI, Kertin, Sarawak, Minimas, UTP. Okay. So as for the sponsorship or financial assistance and financial support, I cannot talk much about that. Okay, but based on my experience, I'm going through Petronas lah. But bear in mind, sometimes you can search for other alternatives as well. You can search for Mara, JPA, Shell, Repsol, whatever that is you can see lah, whatever you can grab. But bear in mind the requirements that is needed. Sometimes there are sponsors that accepting your SPM trial results, but will only start sponsoring you if your SPM result is good enough. Okay, so if you are enrolling in any campus using your SPM trial result, you need to be more careful lah, in make sure that your first semester result is good and then your SPM result is good too. So the safer option is to request for the campus that you want after SPM result is out. That is the safer option. Okay. Next, okay. We go after higher learning institution, we go to career path lah. So in what kind of industry we can see process control engineer? Pharmaceutical, manufacturing, pulp and paper, these are the examples lah. Semiconductor, petrochemicals, refinery, oil and gas in general, utilities, food and water. Okay, this one is salary range. Okay, as per requested lah. So salary range based on years and experience. This one is taken from a website for recruitment lah. So recruitment website put this salary range based on years of experience. Okay. So 0 to okay, I'm not gonna read each one. So I give some time for you guys to view lah. Okay, but I read some of it. So if you are going for as general as a chemical engineer, so chemical engineer usually refers to lots of industry lah, can be pharmaceutical, manufacturing or others. 0 years of experience, that means fresh grad. or up to 3 years, you can get from 1700 to 2600. That one is based on what is publicly known lah. There are some companies that can pay higher or even lower than that. Okay. And then for chemical engineer, to get at least a 5-digit salary, you need 15 years of experience lah. Okay, but there's a but here. This one is solely depending on your degree certificate. So there are other methods to increase your potential salary is by register first after graduating. You need to register with Board of Engineers Malaysia, BEM, Lembaga Jurutera Malaysia, to become Jurutera Siswaza, graduate engineer. After at least 3 years of experience, after 3 years of registering, you can apply to become IR, engineer. And if the company that you are working supports the IR, you can increase your salary. You can increase your salary more lah, in addition to your years of experience. Okay, that differs from company to company and your experience as well lah. And to get IR is minimum 3 years, but usually rarely people can get IR with just 3 years of experience. The assessor or the interviewer will usually advise to go for at least 5 years lah. Because not many people can gain so many experience to become a professional engineer in just 3 years. So the 3 years is minimum, but you can learn more, okay, by gathering more experience lah down the line. Okay, so what is the future for process control engineering? Okay, that's right. Okay. So the future that we need to consider or is actually happening now is first optimization and integration. So as I mentioned, the last goal of process control engineer is to ensure efficiency of the equipment, efficiency of the process, efficiency of the plant. So one of the ways or one of the things that is need to be considered is integration. We can integrate in smaller scope. We can integrate between the same production line. That means from input processing into output. If we have multiple stages or multiple process line, we can integrate them based on resources. The integration can go in between different processes as well. For example, let's say we need to use electricity. So the electricity can come from either from our own, we have our own generator, or we can utilize from Tenaga Nasional, for example, ataupun Sarawak we have Sesco. So the integration between various parties, various process equipment is very crucial lah. Even in heat integration, for example, if we have extra energy, we have extra heat, the extra heat can be channeled somewhere else for the other process that requires heat, for example. This one is more critical and more critical as of now, cyber security. So now with various concern on phishing, Trojan, various kind of malware, virus attacks, it is more pertinent, it is more important for us to always update our software, always update with the current patches, current software, and just to get to know lah what are the new security measures we need to take. Because sometimes people can hack, people can gather our information without us realizing and without any harm to us for now. Okay, but then the information can be utilized, either can be sold to dark market, to competitors, or just for fun. People can just shut down our plant for fun. just to see the world burn, for example. Okay, just to see we scramble ourselves. Okay, and knowing that our processes are involving stuff that can explode, natural gas can, stuff that can explode, chemicals that have toxicity, it is more crucial to ensure that whatever that is controlling the plant is ourselves, coming from our side lah. Okay, next, data as commodity. So as I mentioned, from data now we can analyze and give further instruction. For example, for artificial intelligence to work, it has to rely on first descriptive analytics. We know how to describe first. And when it knows how to describe, it can predict. When it can predict what can happen to the plant, next is to prescribe. It can give advice. Okay, so data, how to collect to make sure whatever data there is, whether it is intentional or non-intentional, even process incident, process accident, fatality, even stuff like that is a data as well that can be required, can be used for improvement lah. Okay, and lastly, virtual and augmented reality. Okay, this one not necessarily related to control directly or totally, but then we can see that one of the constraints for process control engineer to do adjustment is if the plant is alive, the plant is in operation, if we do wrong adjustment, the plant will shut down. Or worse, the plant will be gone now. So virtual or augmented reality is required to ensure that whatever that we do, we can test it at some other stuff that is non-dangerous before we applying the actual design to live plant. Okay, so there is some of the some futuristic features that is either already here or will be improved further in coming times lah. Okay, and thank you for your question. So that is all. That is all as for the slide goes. That is all from my presentation. If there is any further inquiries or questions from the floor, Tasnia?
Okay, just to recap, Encik Anwar dah share maksudnya as a process control engineer itself, different industry, they can work in different industry as well kan. Tapi maksudnya untuk Encik Anwar personally, because you work in the oil and gas field, so what you just shared with us in the second slide was the pipelines of oil and gas industry specifically, betul kan?
Yes.
Yeah.
Yes.
Second one, yeah. Okay, but would the job scope differs across this industry? Maksudnya skop pekerjaan tu berbeza ke kalau industri lain macam pharmaceutical ke food water, or would it be the I think it would be different tapi mengekalkan empat aspek yang penting ni lah macam
Betul, yes. In whatever industry, be it pharmaceutical, automotive, even paper production, a process cannot be, we cannot produce if our plant is not stable. Okay, that is most basic. So stability can come from either from us, process control, we do adjustment, or even as simple as the maintenance guy repair the equipment. And then everything just become okay, smooth, easily. So when our plant is stable, then we can focus to quality compliance to achieve the specification that the customer wants lah. In our case, the customer wants is in terms of temperature, in terms of heating value, how many joules that we are supplying. And then when the quality is as per customer wanted, only then we can produce as much as we want, as much as the customer need. And then as we produce more and more, we know okay what we can do, what we need to do to make sure the process is more efficient. So these 4 steps or 4 rules are applicable across whatever industry or line of work that we are in.
Okay, faham, understood. Alright, untuk subjek yang perlu dimata lah dalam untuk teruskan kerjaya dalam as a process control engineer. Tadi Cik Anwar ada mention about the data collection. Yeah, this one. Data collection and analysis is important, right? So mungkin boleh share sikit apa subjek-subjek during matrikulasi dan juga subjek teras yang penting untuk dalam kos ni, dan subjek sewaktu SPM apa subjek-subjek yang penting untuk pelajar-pelajar tekankanlah untuk skor kalau mereka berminat untuk teruskan to be a process control engineer. Maybe like penting ke data analytics? Other subjects like you learn during university?
Okay. I start daripada sekolah menengah dulu lah kot. Sebab ni yang the most basic kan. Okay. So the most basic thing kalau relate to kalau process control kita pecahkan kepada dua. We split into two lah, process and control. So process can be diverse or different, but the ones that usually touched upon during our school years are usually physical process, that is usually heat related, because in university we will learn about thermodynamics. So all the laws of thermodynamics, the flow of energy, all the heat capacity, specific heat capacity, latent heat, that is for sure we will need to know further lah. Okay, first. And then chemistry related, reaction, rate of reaction or reaction in general, acid and bases for example. What influences the reaction lagi. And then if some of us be involved in pharmaceutical or biomedical engineering, some knowledge in biology may help, kan? Because some of the processes, for example, osmosis. Osmosis can be happen when we control the difference between concentration. Kita kawal kepekatan dari satu kawasan ke kawasan yang lain untuk gerakkan cecair itu. So there is some basic knowledge on bio unit as well. Tu kalau proses. Pasal apa? Gas law. Gas law akan berguna untuk fluid flow. Sebab kita nak tahu gas ataupun cecair itu bergerak macam mana. Suhu yang akan tinggi akan menyebabkan apa jadi pada bahan kimia tu. Lagi apa? Itu proses. Kalau on the control part, what is required, yang based on my experience lah dalam 5 tahun kerja ni, biasanya akan berguna is first your knowledge of trigonometry. Okay, kenapa trigonometry? Trigonometry has the reputation of only related about triangles, right? But no. Trigonometry in the most basic form or the original form is to describe behavior that is repeating, cyclic behavior. That is then translated into something we know as kalau kita rujuk pada matematik tambahan. Kita belajar pasal unit circle. And then we learn about circle. We simplify about circle. And then to simplify further the circle, it becomes triangle. Okay. So jangan tertipu yang kata trigonometry ni pasal segitiga. Segitiga tu is a heavily simplified presentation of trigonometry of behavior sebenarnya. So in process plan, what is cyclic or what is repeating behavior is the movement of our products as we travel across the pipeline, kan. Of course, the flow ada naik turun, it fluctuates. The temperature has up and down. So the pressure ada pressure fluctuation dia. So we describe that using trigonometric function. And then the second thing we need to learn is calculus, ataupun kalau dalam AdMed kita belajar pengkamiran, integration dengan differentiation, pembezaan. Because we always have to know about if integration, why we need, because we always want to know the area below the graph, because area below the graph represents how far is our process going away from our target. The larger the area, the larger it goes away from our target. And then differentiation we need to know because we want to calculate the rate of change of a process. And then the one that is most required, commonly required, if we observe in this diagram, is statistic lah. The two most common metric of statistic is when I mention about fluctuation is standard deviation, and then we shift the mean, shift the average. That's the list of we need to know lah about statistic. And then to know
we need to be all the three sciences subjects lah, biology, physics, chemistry and maths, additional maths, very important. Okay.
Very important. And then related to data science, a little bit of programming or logics can help lah, because bukan semua benda kita belajar masuk-masuk, saya cakap earlier, bukan semua benda kita start terus pandai. Kadang-kadang ada training yang hanya dengan masuk kerja baru kita boleh belajar. Sometimes the company provide the training, or sometimes we need to learn ourselves. But then we know, we can only know what we need to learn after we start doing it lah. So sometimes the software, the technology that is required comes after we we enter the job. Okay.
Alright, kita ada soalan. I want to ask, what is your opinion on jobs demand of this field in the future? Mungkin tadi Encik Anwar pun ada dah terangkan the future of the field itself, tapi mungkin ada yang Encik Anwar nak tambah ke?
Okay, future job demands. Okay.
Yeah.
Okay, future job demands. I cannot say much, but from what I see lah, process control, it has the potential to be relevant more in the future. Okay, why? But then, how to say, to become fully expert, or to become at least minimum expertise for process control engineering, requires many exposure in either process or instrumentation or plant operation. Okay, as I mentioned. But in my case it's different lah. I fresh graduate, I terus masuk dalam proses control. Okay, tapi itu pun berkait juga dengan job demand or job market lah. Kerja ada kat situ je, so kita tak boleh memilih kata, oh saya baru grad, saya belum expert lagi. Tak boleh. In my case tak boleh lah masa tu. So kita terjun je masa tu. But then as time goes by, kita belajar lah sikit demi sikit. So kenapa bagusnya process control engineer ni? Sebab dia we can say it is jack of all trades but two master of none. Dia tahu banyak benda tapi tak terlalu mendalam. So okay, tapi salah satu persepsi ataupun kecaman lah yang terjadi kepada proses control engineer adalah kita dengan ada satu, by having one process control engineer, we can eliminate process engineer, we can eliminate instrument engineer, we can eliminate plant operator. That is not true lah, because why? Because despite knowing these three topics, kita still seorang, we still one person, we cannot do that much thing lah. So so just knowing doesn't mean that you can do everything. And then and how to be more relevant as a process control engineer or process engineer in general, we always have, okay, we always to be value driven or cost conscious. Always strive to get the most out of whatever we're doing lah, or doing more, doing the same with less resources. That is the essence or the foundation lah, I would say. That is the foundation for becoming a process control engineer, because okay, I mentioned earlier, we need to have stability first, right? That is the step, the sequence. But then kita selalu dengar kan, begin with the end of mind. So untuk tahu apa cost yang kita dapat kurangkan, to know the benefit that we can increase, to know what cost we need to save, only then we know what kind of stability that we need, what kind of quality that customer wants. Only then we know. So if you have this quality, and then if you refer the attitude or sikap yang kena tu, you can survive long enough lah. Always curious, always dig further, collaborate, and then be open to learning. Okay, so okay, menjawab kan. So process control engineer will be very relevant. Cuma depends on which company wants you or not lah. As a career, you will stay. Don't worry.
Okay. Alright, Encik Anwar. Ini apa, saya macam nak recap balik sebab just to make it clear, maksudnya in every organisation, in every like manufacturing company, we are producing products kan. So we have each company we have our own like plant and equipment, plant and machinery, which you, the process control engineers, are the one who is in charge lah to ensure all these plants will produce good production of products, betul kan?
Betul.
Okay, so saya just nak bagi mungkin a clear penerangan lagi kalau kita ambil contoh industri pharmaceutical. So diorang produce drug, ubat lah kan. Maksudnya different drugs may have different temperature untuk dikekalkan, maksudnya to be preserved under certain temperature. So mungkin the plants, the equipment to produce all these drugs berbeza-beza lah kan, mengikut drugs yang kita nak produce, company nak produce. So you as a process control engineer would memastikan all the plant equipments atas 4 aspek tadi lah. Maksudnya the stability to produce the products, the quality of the products, macam mana quality products akan terhasil daripada plant yang pharmaceutical company tu ada, betul tak?
Betul.
And then the production of the drugs, and then the efficiency of producing the drugs lah towards the company tu lah.
Betul.
Okay, faham?
Yes.
Alright. Para pelajar kalau ada soalan lagi silakan And then saya nak tanya, okay, tahap education required untuk position ni itself, would you say a bachelor degree level would be enough, or should they go further for masters or PhD, or does it depends on which management level that you want to pursue?
Okay. If you are pursuing, okay lah. In the case, kalau kita nak start kerja, makan gaji, bachelor's degree, kalau Malaysia lah, bachelor's degree is sufficient. Okay, dah cukup dah. Further studies, okay, further studies, kalau you nak pergi kepada pangkat yang lebih tinggi for in management, that means you're pursuing masters or PhD in management stuff lah. Kan, MBA, business school or
But does the IR title required?
Okay, the IR is specifically on your based on your experience, and then based on the assessment by the interviewer, and as well as dia ada dua cara, sama ada by your supervisor, if you have supervisor, the assessment by supervisor first before you go to interview, or if you don't have any supervisor, what do you write in your report? Okay, so from the report, the interviewer or the assessor will check, will inspect you on your capability of doing analysis and how deep or how well versed you know in the field, in whatever field that you're working on, before they allow you to go for assessment.
Okay.
Okay.
Faham? Alright. Okay, one last question. I did a bit of research. So it's like I encounter satu explanation ni lah. Process engineer and also control engineer. Is it two different things? Process
Okay.
engineer.
Okay, as I mentioned, kalau control engineer, dia sebab dia macam mana? Dia asalnya daripada instrumentation and control engineer lah. Okay, so instrumentation and control engineer ni dia daripada cabang electrical ataupun elektronik. So bila dipadankan dengan knowledge in process, dapatlah proses control.
I see. Alright.
So tapi in some industry ataupun some companies, walaupun jawatan dia instrument ataupun control engineer saja, background electrical and engineering pun sebenarnya boleh jadi process control engineer. Maksudnya dia belajar pasal proses tu bukan daripada zaman universiti, tapi bila dah kerja baru dia kerti pasal proses tu lah. So you boleh kerja ikut jalan tu juga. So ada macam based on my experience pun memang ada orang macam tu lah dalam I punya department. Ada orang start as chemical engineer student, ada yang start sebagai electrical engineer student. Tapi maksudnya just beza apa yang kita belajar dulu dan apa kita belajar kemudian lah.
Faham.
Faham.
Okay, kita pun dah sampai ke penghujung sesi. Mungkin any last words to encourage the students to explore more on this career apa-apalah.
Okay, so no more question. Okay, so I would like to first gratitude lah. Thank you to ANSARA Taiping for inviting me for this sharing. Okay, this is quite a refreshing moment lah. Tambah pula ni hari pertama kan, 2021. So quite motivational lah for me to share on our line of work. Okay, and then what drives me to do this sharing? Kenapa? Sebab satu, in engineer as general term, something yang kita biasa dengar kan. Macam apa yang hebat sangat, apa yang kita kena tahu. So I hope this one can shed some light lah. Macam especially process control ni, I would consider dia sebab banyak sangat benda kena tahu sebelum boleh jadi process control engineer. Sebelum kita boleh start buat kerja process control engineer tu, kita dah kena belajar dah pasal proses, segala alatan equipment yang kena ada, macam mana technician operate plant tu dan sebagainya. Itu pun dah kena tahu dah dari awal. So for me, kepada siapa-siapa yang nak teruskan, nampak bidang ni menarik, boleh teruskan, tapi ingatlah dia kata-kata waspada je ataupun caution dia adalah in whatever field that you are pursuing, first check your objective first. Kita nak capai apa sebenarnya? Ada setengah kita ni rigid on field yang kita nak, sebab kata aku dah belajar satu sama ada aku dah belajar benda ni, kenapa aku nak buat benda lain? Ataupun kedua, benda ni masa belajar dulu aku rasa susah kerja, jadi bila datang masa kerja aku tak nak masuk dalam benda ni, trauma. Macam tambah pula proses control ni, dia punya reputation among chemical engineering students is a hard subject. As a subject, yes, dia ada challenges dia, I admit. But then once you see the practicality, bila kita nampak cara kita amalkan knowledge tu dalam masa kerja, akan jadi sangat best. So kan. So benda yang kita rasa macam sekarang pun, even SPM pun, kita rasa lah bosannya buat differentiation ni kan. Integration by substitution lah, sakitnya hati kan. Memanglah masa kerja kita takkanlah sepanjang masa menulis kat papan hitam integration, trigonometry tu semua, tapi dia sekadar bagi kita platform untuk kita faham, komputer aku kat office ni dia boleh operate plan sebab dia buat differentiation macam ni. Dia tahu rate of reaction macam mana, dia tahu dia calculate the error ataupun dia calculate the target macam mana. So whatever that you are learning now, no matter how boring, how hard, how trivial, betapa remehnya pun benda tu, jangan sekali-kali campak ke tepi lah, sebab kita takkan tahu berapa tahun kemudian kita akan guna balik. Macam I tak pernah expect lepas 5 tahun kerja I still kena beli buku rujukan math sebab I nak faham cara dia kira tu kan. Tapi eventually kita akan cari balik. So respect your knowledge, whatever you're learning, kita takkan tahu, kita akan guna balik. And then kalau nak pursue whatever your interest, check balik niat kita, benda tu align ke tak. Jangan hanya sebab nampak benda tu tak best, kita terus ni lah tolak ke tepi. Kadang-kadang lupa benda tu best sebenarnya. Dan kalau nak if you have all the attitude, skill and knowledge macam yang cerita tadi, go for it lah. Sebab proses control engineer ni has high reputation on connecting value kepada proses. We ensure the process can achieve whatever value that the company wants.
Betul.
So if you can see the connection, go for it lah.
Alright, kita sebenarnya dah kesuntukan masa, tapi ada one last question which I find it quite interesting. Dia tanya how you personally develop your passion before pursuing towards this field. Mungkin secara ringkas Cik Anwar boleh share sikit personal interest tu macam mana, how did it develop, macam how did you know that you want to pursue yourself in process control engineering?
Okay. In my case, I pursue before I have the interest.
Okay.
Okay, faham kan? But in general sense,
most are like that.
Most of us are like that kan. Kita ada interest after kita dah masuk dalam bidang tu. Tapi macam ni kita nak tahu kan. Macam mana, apa soalan ni, macam mana kita nak ulang balik?
Develop passion sebelum pursue this field. Tapi in your case maksudnya it develops along the way waktu zaman belajar ke macam tu? Ataupun bila you dah start kerja in the field?
Okay. Dia bila dah start kerja sebenarnya baru kita dapat passion tu. Tapi suatu I mention, tak kisahlah betapa bosan, betapa remeh, betapa tak sukanya kita kepada apa kita belajar, jangan buang. Sebab mungkin pada masa kita suka, bila dah start kerja tu, baru kita, ilmu ni sebenarnya aku perlu rupanya. So the passion comes after, but make sure that you have the patience, first to endure or whatever curriculum structure, whatever subject, whatever test that is coming your way. When you come to work, you develop the passion into specific in whatever you do. Macam in my case, kita belajar je semua fluid movement, kita belajar je pasal reaction, kita belajar je pasal programming. Tapi bila dah masuk dalam line kerja, baru kita tahu, okay, this one yang aku pernah belajar 4 tahun lepas, I need to study further. This one yang aku pernah belajar masa SPM dulu, okay, I need to study further. Tapi kalau kita abaikan, kita buang terus daripada awal, lebih banyaklah kita kena mengulang kaji semula berbandingkan kalau kita simpan memori tu sikit-sikit kan. So Dia kena macam jentik-jentik je dah boleh belajar. Macam tu lah. Okay. Okay, menjawab soalan tu.
Hello.
Hello. Hello. Okay.
Assalamualaikum.
Hello, boleh dengar ke? Sorry. Saya
Okay.
yang terputus ya.
Okay.
Saya boleh dengar. Boleh dengar. Okay.
Tasnim.
Hello.
Tasnim.
Lambatlah line nambahin.
Tasnim. Okay, Cik Farid, Cik Anwar Farid. Saya Cikgu
Okay.
Aisyah. Saya Cikgu Aisyah.
Okay. Okay. Baik. Ya.
Maaflah saya bercelah sikit.
Tak ada lah.
Apa dah?
Saya suka bila Cik Farid cakap pasal tentang passion pelajar tu.
Ya,
dalam satu
cikgu. Sorry. Line saya putus.
Tak apa. Cikgu borak dulu dengan Farid.
Cikgu dengar
Cik
ke?
Farid. Saya dengar,
Okay,
saya dengar.
boleh.
Saya tengah berkomunikasi dengan Cik Anwar. Cik Anwar Farid ni. Okay. So Cik Farid, apa pandangan Cik Farid
Hello?
pada pelajar? Apa pandangan Cik Farid
Hello?
pada pelajar yang dia di sekolah dia sangat struggle dengan dia punya akademik. Dia sangat struggle dengan akademik dia, tapi dia sangat berminat dalam bidang-bidang yang macam ni. Pertama sekali bidang-bidang yang berkaitan dengan engineering ni kan. Dia sangat suka, tapi cuma dekat sekolah dia sangat struggle untuk dapat keputusan yang bagus. Kalau kita kata keputusan dia ni nak bawa ke course yang dia nak tu agak sukar. So apa nasihat Cik Farid pada student macam ni? Yang kita tahu dekat sekolah dia sangat struggle, tapi dia memang sangat minat dengan benda macam ni.
Okay. Kalau struggle tu is a general term lah. Tapi saya boleh kata macam ni lah. Selalunya the struggle sebagai student, kita struggle kita rasa sebab apa? Sebab first kita nampak apa yang kita belajar tu adalah sebagai first sama ada benda yang sekadar untuk lulus exam, lulus whatever assessment. Yang kedua, kita tak nampak dalam bentuk aplikasi benda tu dalam dunia sebenar. Bukan dunia sebenar lah, dalam kehidupan seterusnya. Okay, kalau kita belajar, contoh kalau saya cakap X sama dengan plus minus B square root 4 tolak AC. Okay, itu quadratic equation kan, saya tulis. Tapi kalau saya sebut macam tu je, orang takkan faham. Sehinggalah kita lukis sendiri quadratic equation tu dan kita tahu, okay, quadratic equation contoh paling senang kan. Dia ada satu lengkungan yang mana dia akan ada satu titik mula dan titik akhir dia. Dua titik sebab ada X. Kita tahu kalau dalam bidang yang kita akan aplikasikan benda tu secara amali, kalau fizikal biasanya kalau kita nak kira jarak menembak contohnya, kalau orang tu seorang penembak lah ataupun pemanah. Kalau macam dalam case programming komputer, dia guna quadratic equation ni untuk menentukan kalau ada dua jawapan bagi setiap perkiraan yang dibagi. Jadi sebenarnya untuk struggle tu, struggle is kita nampak keputusan dia pada grade lah, pada result SPM, pada markah yang dia dapat. Tapi bila berkait dengan soalan ni dan soalan sebelum ni lah, passion tu kan. Passion tu ataupun minat tu datang bila kita cukup first ada kesabaran, ada patience untuk kumpul je segala apa yang kita belajar, jangan buang. Tak kisah betapa kecil, remeh, bosan, sakit hati belajar benda tu je dulu. Untuk kita tak tahu kita akan guna bila. Yang kedua adalah benda tu sebenarnya perlu diterjemahkan kepada benda yang praktikal lah. Kita belajar pasal inertia. Senang nampak kan inertia sebab kita kalau break kereta terlajak ke depan. Okay. Tapi benda yang lebih besar daripada tu, kalaulah kita masuk dalam industri, cerita pasal drive lori. Kenapa lori tangki tak boleh? Tangki dia satu tangki besar, kenapa tangki dia perlu dipisahkan? Itu perlu lebih penghayatan dan penceritaan lah. Sama ada pelajar tu sendiri yang cari ataupun diberikan oleh sama ada cikgu ke dan seumpamanya, ataupun kita bagi tempat-tempat benda tu boleh dijumpai. Macam zaman berapa tahun lepas, 10 tahun lepas, zaman saya SPM, sumber untuk belajar benda-benda macam ni agak kurang. Sangat-sangat kurang lah. Sekarang benda tu dah mudah didapati walaupun dalam sumber yang kita boleh kata darah sekalipun. Tapi kalau kita type keyword yang betul, kita akan jumpa benda yang bagus tu lah. Macam saya pun sekarang ni, hampir walaupun dalam kerja ni, saya akan luangkan masa untuk buka YouTube, cari YouTubers yang merangsang pemikiran lah. Contoh macam ada channel-channel YouTube yang belajar pasal matematik, pasal knowledge in general. Contoh yang boleh saya bagi, yang boleh saya petik macam sekarang ni, contohnya kalau satu channel ni Veritasium, nanti boleh cari. Saya letak rancak lah nama penuh dia, Veritasium. Three Blue One Brown kalau siapa yang minat dalam matematik. Cara dia present contoh matematik sangat animation yang sangat best lah untuk ditonton. Contoh dua tu. So tu kalau YouTube lah. Kalau kita buka kepada social media pun banyak je yang menggunakan platform ni untuk belajar. Jadi dia sebenarnya adalah satu, kita kat zaman kita untuk simpan apa kita belajar tu. Yang kedua adalah macam mana kita terjemahkan apa saja kita belajar tu ke dalam bentuk yang kita senang faham ataupun seronok nak tahu lagi. Jadi itulah kot. Jawab ke Cikgu Aisyah?
Yes, sangat menjawab. Sebab saya sebenarnya nak beritahu kat pelajar yang memang betul dia akan struggle di sekolah. Sebab sekolah lah bercerita tentang persaingan kan. Persaingan ni bukan berkaitan saja dengan pelajar lain tapi dengan kos yang dia orang nak dengan mereka nak ambil nanti. Jadi cikgu rasa sebenarnya satu yang bagus adalah terus je berusaha, betul tak? Terus je berusaha dan sentiasa tak apa ni, dia minat, kalau minat tu betul-betul buat, betul-betul sampai jadi, betul tak? Kan? Right. Very good. Memang betul. Thank you.
Cikgu, sorry terputus tadi.
It's okay, Tasnim, it's okay.
Okay, alright. Mungkin untuk tu je lah untuk sesi kita hari ni saya nak ucapkan terima kasih banyak-banyak untuk speaker kita, Cik Anwar. It's a very good sharing honestly, sebab saya sendiri pun memang baru kenal lah proses control engineer career ni, dan juga you yourself, your enthusiasm and your passion towards maksudnya the learning process never stops lah, so it's something to be admired to all of us. So jadinya terima kasih untuk sesi hari ini. Mungkin dah tak ada apa-apa dah dari saya. Cik Anwar ada apa-apa lagi ke nak tambah?
Itu saja. Terima kasih. Dah dulu pula tadi kan.
Okay. Alright. Jadinya kita tangguh sesi kita dengan tasbih kafarah dan surah Tu'as. Terima kasih banyak Cik Anwar.
Terima kasih banyak Cik Anwar. Terima kasih.
Pedas lah.